All right, geometry students, Mr. Peterson here. I am out for a few days this week, so I'm bringing this lesson to you through a video recording here. So what we got today, we are on lesson 2-4, and we're going to be taking a look at slope. So the first thing we're going to do is review what slope of a line is, do a quick review of that, and then we're going to use slopes to identify two things. We want to find parallel lines and perpendicular lines. All right, so that's kind of what we're up to today. So let's dive right in and see what we got. First of all, what slope is, it tells us what the steepness of a line would be. Okay, so when we're looking at slope, we would identify, if we have a line like this one over here on the graph, we would be identifying how steep that line is. So we'd be looking at the rise over top of the run, how far up and then how far over it takes to go from one point down here to the next point over here. Okay, so it should be a review from middle school math and even some algebra 1 from last year. We can take and find the slope using the rise and run. So we would get a ratio here, a fraction that expresses what the slope is. So that's one way to find it, is by looking at it on a graph. Another way to find it is if you know what 2 points on the line are, you could use this slope formula here and you could manually calculate what the slope is. Okay, so just a quick review. We could find it on a graph using something like this over here, or we could find it using the slope formula. Either way would get us a slope calculation. Okay, we're going to be using both of those today. So let's dive in and we'll take a look at our first problems we're going to look at. Before we do that, we do need to talk about what makes lines parallel and what makes those lines perpendicular. Okay, so we have some theorems here, just like our other theorems in geometry. So our first one here for parallel lines, it reads, in a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. Okay, so if two lines have the same slope, then we know that they are going to be parallel. We also have this piece of information here. Any two vertical lines are automatically going to be parallel. Okay, so what they're meaning is if you had a coordinate grid like that with your x and y axis, and if you had two perfect vertical lines, okay, and if we could tell that they were perfectly vertical, then we could identify them as being parallel right away without doing any calculations whatsoever. Okay, perpendicular lines. How do we know two lines are perpendicular? This theorem tells us in a coordinate plane, two non-vertical lines are perpendicular if and only if the product, okay, so multiplying, the product of their slopes is -1. Okay, so we're going to take a look at that. All right, and then they also give us this piece of information here. Vertical and horizontal lines are perpendicular automatically. Okay, so again, if we have that a coordinate grid here with this our x and y axes, and if we have a perfectly horizontal line, okay, and if we have a perfectly vertical line, then we know that those two lines would be perpendicular. Okay, so there's our perpendicular symbol. All right, so let's take a look at these perpendicular lines a little bit more, and the product of their slopes being -1. Okay, so let's say we're looking at some perpendicular lines, and if the slope of one of our lines is expressed as a fraction as a over top of b, then the slope of a line that is going to be perpendicular to this one right here, its slope would look like this. All right, it would be negative b over top of a. Okay, so take a look at what happened. First, it went from being a positive slope to a negative slope. So that's one thing that took place between those lines. And our numerator and denominator got reversed. Okay, they got flipped. All right, when that happens, we call that those ratios, those fractions for perpendicular lines are called negative reciprocals. Okay, there's the terminology for that happened when they became opposite of what they are, when their signs became opposite and their numerator and denominator also flipped. Okay, so to give a real example of that, let's say we have one line that has a slope of 3/4. If a line was going to be perpendicular to that one, its slope would need to be -4 over top of 3. All right, that's what we're looking to identify if we're trying to find perpendicular lines. Okay, that process. All right, so let's take a look at some of our first problems we're going to work out now that we have some of that background knowledge. Okay, so first what we have is we want to determine if segments UV and XY are either going to be parallel, perpendicular, or neither of those. Okay, so we got three different options. All right, and take a look. They give us the coordinates for UV, so they're telling us where UV is at on a coordinate grid, and they're also giving us the coordinates for X and Y, okay, where that segment would be on a coordinate grid. Okay, and to calculate what the slopes are, because that's what we need to do, we need to find the slope of each of them so that we can compare and decide what type of lines they are. All right, so we're going to be using the slope formula to do that. Okay, so first let's work with segment UV. Okay, so if we were going to use the slope formula with these 2 points U and V, our first step, just like we did back in topic 1, we would label one set of our coordinates x1, y1, and the other set of our coordinates x2, y2. All right, once we have that, then it'd just be a matter of plugging them into the slope formula and seeing what we have. Okay, so let's take a look. It's already been done for us. All right, so the slope of UV, okay, if we take those numbers and plug them in to the slope formula, all right, here's what we would end up with. All right, take a look. You got your y2 minus y1 on top and your x2 minus x1 on the bottom. And if you simplify that and work it out, you would get -3 over top of -1, which would simplify down to just a +3. Okay, so there's our slope calculation for UV. All right, let's take a look at what happens if we calculate the slope of XY. All right, so we'll take X and Y next. So again, we're going to label one of our coordinates X1, Y1, the second set as X2, Y2, and then we're simply going to plug those coordinates into our slope formula and see what type of a slope it generates for us. All right, so our slope of XY, if we plug those numbers in, okay, that is what it ends up with. We have our y2 minus y1, our x2 minus x1. And if you simplify that and do the math with those, we would end up with 2 over top of -6. Simplify that down all the way, and we have -1/3. Okay, so now we need to compare the two slopes and see if they meet any of the definitions of being parallel, perpendicular, or are they neither of those options. Okay, to compare them appropriately, let's throw a 1 underneath of that 3, and then we're able to take a look at them better. And if we can see what's going on, let's flip back to, well, let's take a look at this first. We have this one is 3 over top of 1, and it's positive. Okay, and this slope down here, it is negative, and now it is 1 over top of 3. Okay, if we flip back to what we just looked at with these negative reciprocals, that's exactly what took place. All right, it was 3 over 1. Now it's 1 over 3, and where it was positive, it is negative. So that means that these two lines are going to be perpendicular. We'll throw our perpendicular symbol there. Okay, and another way we can check if they're perpendicular, I'm going to go back to this language here about their product of their slopes is going to be equal to -1. All right, so we can multiply our two slopes and see if they're going to be equal to -1. So if we do that, let's get some space here. All right, if I take both of these, so we have a slope of 3 over top of 1, and we're going to multiply that by negative 1 over top of 3. Okay, if you do the math on that, you're going to get negative 3 over top of 3, which would simplify down to negative 1. So that's a good check to see if your slopes are actually perpendicular. All right, they met the definition of negative reciprocals right here, and then they also met the definition of the theorem that says the slopes would multiply to negative 1. All right, leaving us with that conclusion there is that those two lines are perpendicular. Okay, let's check out some other examples we're going to take a look at. Okay, we can also tell whether lines are going to be parallel or perpendicular by looking at a coordinate grid and those lines being placed on that grid and finding out what the slope is of those lines. All right, so same thing. We're going to determine if these lines are parallel, perpendicular, or neither of them, of those options. First, we're going to check out K and N. All right, so we're going to determine if what type of relationship would exist between K and N. Okay, so here is line K. So the first thing we want to do is find 2 points on line K. So I see one point is right there. Okay, and then if we move further down line K, we want to find a spot where it crosses on our coordinate grid perfectly. Here's our next spot right there. Okay, that can kind of be tricky, trying to find a spot where it meets both of our x and y axes on the numbers the right way. Okay, so now that we got 2 spots, let's find our rise over run. So our rise is going to be rising 1, 2, 3, 4, 5 for a rise. Okay, and then we have a run of 1, 2, 3, 4. Okay, so this line is going to the left, so it's automatically going to be negative. So I'm going to write this down. My slope of K, it is a negative, and it was a rise of 5 and a run of 4. Okay, so we're going to have 5 over top of 4. All right, so there's our slope of K. Now let's identify our slope of N. I'm going to get rid of some of these lines so I got some space to work. Okay, so my slope of N, same thing. I want to find 2 spots on N where it crosses really nicely to be able to find slope. Okay, so there's 2 spots right there. Okay, so N, if I write this down, N is equal to, it is also pointing to the left, so it's going to be a negative slope. All right, and my rise over run on this, I'm rising 1, 2, 3, 4. And then my run is 1, 2, 3. Okay, so there's my 2 slopes. Now I want to see if they match any of the definitions for parallel, okay, which they don't. They don't match the definition of perpendicular either because these do not follow the rules of negative reciprocals, or they do not, their products would not come out to negative 1. So this one is going to be neither. All right, it is neither perpendicular or parallel. Okay, so there's K and N evaluated. Let's take a look at our next 2 lines we're going to check out, and that is going to be M and Q. Okay, so on line M, same thing. You want to find a spot where you can find your slope. So find 2 points from line M. There's 1 point. Here's another point here. Okay, so it looks like it's going to the right, so that's going to be a positive slope. And we're going up 1 over 3. Okay, so for M, we have a positive slope, and it's going to be 3. No, wait. It's going to be up 1 over top of 3. There we go. All right, there's our slope of M, 1/3. Now we need to take a look at our slope of Q and see what we have there. So again, find 2 points on Q. Okay, there's one there. And let's see, where's another one? Right down here toward the end. Okay, now we just want to take our rise over our run for Q. Q is pointing to the right, so I know that that's going to be a positive slope. And it looks like we have a rise of 1, 2. And we have a run of 1, 2, 3, 4, 5. Okay, so looking at those, go back to our rules here. The slopes are not the same, so they're not parallel. They also do not meet the definition of perpendicular. And so it looks like we're left with this again. All right, so lines M and Q are not parallel, they're not perpendicular, so we're going to label these as neither. Okay, so both of them didn't work out to be anything, all right, which is kind of a little sad, but that's okay. All right, sometimes we have that for an option. All right, so there's some examples of how you could find the slopes of the line using a coordinate grid and then identifying what types of relationships you would have between the two lines. Okay, I got one for you guys to try. All right, try this one out. See what you can do. You're taking a look at lines K and J, and you're trying to determine, are they parallel, perpendicular, or are they going to end up being neither like the last ones were? All right, try those. Pause the video here, and then once you get done, we'll take a look at your answers here in about a minute or two. All right, let's take a look and see what this came out to. Oh, we need to get an answer up here for this one. All right, well, let's just work this out right now. Okay, so K, if we take a look at K, let's see, I have a point right there, and then I have a point right there. Okay, so for K, it looks like I have a rise of 2 and a run of 1, 2, 3. All right, and it's pointing to the right, so that's positive. So K is going to equal 2 over top of 3. All right, and then I'm looking at J. Okay, so line J. Let's find 2 points. There's a point there. And another one, oh, all the way up here. Okay. All right, there's 2 points on J. It's going to the left, so that's negative. Okay, so J is automatically going to be a negative slope. And our rise, we're going up 1, 2, 3, 4, 5, 6. Okay, and we're going to the left 1, 2, 3, 4. There we go. Ooh, I think we have something here. All right, so J, if we simplify that down, it's going to be negative 3 over top of 2. All right, and check it out. These lines indeed are going to be perpendicular. All right. You can verify that because it went from a positive to a negative. So we have a switch in our signs. And then also our numerators and denominators flipped around, so we have those negative reciprocals. Okay, we could check it if you take 2/3 times negative 3 over top of 2. And if it works out to be negative 1, then we are good here. So we'd have negative 6 over top of 6, which would work out to be negative 1. All right, perfect. There's your check to tell that they're perpendicular. All right, so there's our relationship between K and J. They are going to be perpendicular. So the next problem type we're going to look at is we're going to be writing equations of lines that are going to be either parallel or perpendicular depending on what we're asked to do. And we're going to write those equations in this format right here. All right, this slope-intercept form, which might look familiar to Algebra 1. We worked with this quite a bit, this y equals mx plus b. All right, and here's the task that we're given. So take a look at the problem. It says line J has an equation y equals 1/2 x minus 3. Okay, so that's the equation for line J. All right, you want to write an equation for a line that would be parallel to line J, and it's going to go through this point over here, K. All right, which we're told is at 4, 1. Okay, so to start writing an equation that'll be parallel to the line that's already there, your first step is to figure out what is your new slope going to look like for your new line. All right, so since here's our old slope. Okay, we have a slope of 1/2 for line J. So we want to create a line that's parallel to line J. So if it's going to be parallel, that means they're going to have the same slope. Okay, so if I already have a slope of 1/2 for J, my new line is also going to have a slope for 1/2. Okay, and now what I'm going to do is take a look at this information. They're telling you that the new line is going to pass through point K, which is at 4, 1, and every single point is made up of an X and a Y coordinate, our values. Okay, so what we're going to do to start making our equation for a new line in this slope-intercept form over here, we're going to take the information we have. So slope is always labeled as m, and we have an x and a y value, and we're going to plug those into this equation over here so that we can start writing our new equation. Okay, so my x value is going to go in for x. My y value is going to go in for y, and my slope, which is m, is going to replace the m here in the equation. The only thing we don't have is this guy over here, our y-intercept. Okay, nowhere in our problem are we told what number to use for the y-intercept. So what we need to do is we're going to solve for the y-intercept. Okay, so take all your values, plug them into your equation. Okay, so start with our y value, which is going to be 1. So I'm going to say 1 is equal to, and for my x value, I have 4. Well, first I need the slope. So my slope is going to be 1/2, so plug that in. So you got 1/2, and your slope gets multiplied by your value for x, which is 4. So we have 1/2 times 4, and then we don't have our y-intercept, so we're going to write plus b because we don't have a number for that yet. All right, so what we're going to do is a couple of small algebra steps to solve for b. So first, let's simplify 1/2 times 4. So we're going to get 1 is equal to 2 plus b. And now we just need to solve for b, so we're going to cancel out the 2. And that's going to get us -1 is equal to b. Okay, so there's our y-intercept of our brand new line. All right, that's where our new line is going to cross the y-axis. Okay, so now we have all the information to write our equation just like this in slope-intercept form. So we're going to say y is equal to, and for a slope, I'm using the slope that I came up with before to make it parallel, 1/2 x, and then for my y-intercept, I'm using what I just found using some algebra steps there. So my y-intercept would be at -1 minus 1. All right, so there is your equation for a new line that would be parallel to J, and it goes through that point right there, 4, 1. All right, if you wanted to, you could graph both of these. You could graph this one and this one to check if they actually are parallel, and that would be a good way to check it to see if you're actually right. Okay, let's try another example. Okay, here we have almost the same information. It looks identical. The only thing different here is we're going to write an equation for a line that's going to be perpendicular to J. All right, passing through the same point. It's still going through that point K. All right, your first step, just like in the last problem, you want to identify what is going to be your new slope for your new line. Okay, so that's step number 1. All right, so if it's going to be perpendicular, our rules for perpendicular, let's say our slope was A over top of B. All right, that means a perpendicular slope is going to be a negative B over top of A. All right, it switches from either positive to negative or negative and positive, and our numerator and denominators are going to switch places. Okay, so if I'm looking at my slope of the current line, which is 1/2, my slope for a perpendicular line is going to be negative, because this one up here is positive, 2 over top of 1. Okay, so there's my slope that would be perpendicular to the current line, and I could simplify that down to make that -2. All right, so I'm going to label that m because that's the slope of my new line to make it perpendicular to the existing line J. All right, then I'll take my coordinates here, my x and y, and all of that is going to get plugged into this equation. Okay, and if you notice, we still don't have the y-intercept, just like the last problem. They didn't give that to us, so we need to plug our values in to that slope-intercept form so that we can generate what our y-intercept is going to be. Okay, so if we do that, let's plug everything in. So for y, we have 1. For our slope, we have -2, and we're going to multiply that by our x value, which is 4, and we're going to put plus b at the very end because that's what we're trying to solve. Okay, a little simplifying, we have negative 8 plus b. All right, and then we're just solving for b. So b would come out to positive 9. So there's your slope intercept, or there's is your y-intercept, excuse me. Okay, now that we got that, we have our b, we have m. Now we can write our equation. So in slope-intercept form, we would say y is equal to, use our new slope, which is negative 2, with x, and then we have a positive 9 for a y-intercept. So there would be our equation that would be perpendicular to our line J, and it would go through points 4, 1. Okay, you could always check it. You could graph this one, you could graph this one here and see if indeed they're going to be perpendicular. That's a way to know if you did it right. Okay, so there's 2 examples. I got one for you guys to try now. Okay, take a look at this problem here. You're going to write an equation for a line that would be perpendicular to line K, and it needs to pass through point T. Okay, so check it out. They give you the equation here for line K, and they're telling you what point line T where, or what location point T would be located. All right, so take that information, see if you can do what we just got done doing, and find, let's see, oh, you're finding one that is perpendicular. Okay, so make an equation for a line perpendicular to line K. So pause the video, and then we'll check your work here in just a couple minutes. Okay, let's take a look and see what you ended up with. All right, so if we first we need to find what our new slope is. Our new slope, for it to be perpendicular, would be this right here. It needs to be negative 4 over top of 3. And we have an x and y value, so then we would plug that into our equation, and down here is what we end up with. So we have negative 2 is equal to negative 4 over top of 3 times 12 plus b. All right, that's what you're still trying to solve for, is b. Do a little fraction math, and you end up with negative 16. Cancel out the negative 16, and you get this down here. B is equal to 14. It's positive. So here's your equation. Y equals negative 4/3 x plus 14. All right, so that line, that equation for that line would make it perpendicular to line K. You could always check them if you want to graph them and see if it actually works. And then you'd know for sure that you got it right. Okay, I hope that worked out for you guys. I have an assignment for you guys that goes with 2-4. All right, so there you go, page 97. See if you can get those problems done in class. And this is our last lesson in topic 2. So the next time you're in class, I have a review assignment for you that will cover everything we did in topic 2, and then we'll get prepped for the test here next week. All right, thank you for watching. I'll see you guys soon.